Over the last few years, a number of database systems have grown in popularity, and these are grouped together under the term NoSQL databases. NoSQL as a category can be a little confusing. These days, that term is taken to mean not only SQL rather than no SQL at all, but it is genuinely a wide category with a lot of options in it. And first, you can't assume that they're all similar to each other. Unlike relational databases as a category, where the skills are broadly transferable between, say, Oracle and SQL Server or DB2 and MySQL, in the NoSQL category, well, just because you know MongoDB doesn't mean you have any head start on learning Neo4j. They're very different from each other. There are no official rules as to what makes a NoSQL database system. And that's kind of the point, because it's more about what they aren't. They aren't traditional relational databases, and they're getting away from those rules. So there's a few things we can say that these usually aren't. This isn't always the case, but most typically they don't use SQL as a query language. Usually they don't store data in tables. A few of them do. Usually they don't really care about relationships. Usually they don't provide ACID transactions, though a few can. Usually they don't require a formal data schema, and that's quite a big deal with the NoSQL databases, is flexibility there. Several have been developed and oriented around web deployment or web development in a way that's not as natural for relational databases to do, simply because relational databases predate the web by about 25 years. And most of them are open source projects, but again, not all. But beyond that, there's a lot of variety. There are a few worthwhile groupings within the category of NoSQL. First, we have several document databases, or more typically called document stores. These are organized around the idea where the fundamental thing to be stored is a self-contained document rather than individual rows of data consisting of well-defined columns that you decided beforehand. Now, it doesn't necessarily mean a document in the sense of a Word document or PDF, just more that everything you store is a self-contained piece of data that describes its own schema. The format you're actually storing might be XML, or it might be JSON, which is just a loose structure where every new piece of data that you store can describe its own schema. In this case, I'm saying store a simple piece of data consisting of two pieces of information, a title and a rating. Title is a string, and the rating is an integer. It's 10. I can turn around and the next piece of data I store has a completely different description, including nested levels of information. And I don't know what this is ahead of time, or certainly I don't need to know what this is ahead of time. I can just store anything I want in this document store. Just keep adding new documents into the database. Each one is given a unique ID, but beyond that you have flexibility, often total flexibility. You don't need to provide a formal schema. You don't need to define relationships. But because you don't necessarily know what's inside each, then the database needs to provide a more flexible way of querying that data than SQL would provide. Examples in this category would be CouchDB and MongoDB, both very popular NoSQL databases. In fact, technically, the XML databases I talked about earlier could also arguably fall into this category too, even though they predate the popularity of the term NoSQL. Now, there's another common category, which is key-value databases or key-value stores. This is another category which is all about having no predefined schema for your data, simply storing and retrieving everything based on a key-value pair. You can kind of make an analogy. This is a bit like having a two-column table with whatever you want in the key column and whatever you want in the value column. Nothing more enforced than that. Could be any data type, integers, strings, large, small, binary data, whatever. You could fit in bits of XML or bits of JSON, so in some sense there's a lot of crossover here with document stores like MongoDB and CouchDB. They could fall both under the document store and key-value store categories. But other well-known NoSQL databases would be MemCacheDB, REAC, and Project Voldemort. Now, worth mentioning is that many database systems in this key-value category are specifically designed to be very fault-tolerant distributed architecture, meaning you easily install them across multiple machines, and no one machine is a point of failure. They'll survive machine failures and keep on ticking. And the last grouping I'll mention are graph databases or graph stores. This is where your data is in a graph structure, small connected nodes. There's no one master point. Everything is connected to everything else. Whereas many of the other NoSQL databases tend to de-emphasize relationships, this goes the other way. It's all about having small nodes of data that have connections to other small nodes of data. It could be a handful, the way that I'm showing them here, where certain nodes manage other nodes that work in other nodes that are located in other nodes. And you can just follow the relationships around. Or in the large scale, there could be millions or tens of millions of these nodes and connections. Neo4j is probably the best example here, though there are others like Allegro Graph. And worth mentioning is some classic relational databases are starting to provide extra features in these spaces. DB2, for example, has the NoSQL Graph Store now. The thing is, there are great reasons for choosing relational databases and great reasons for choosing NoSQL databases, but it's not flip a coin. These things are very different. The most important questions that might steer you away from relational databases. First, do you need a flexible schema? If you can't define a relational database, because when you start to draw out your tables and columns, you just have no idea what they'll be, because the data you need to store will change from moment to moment, that might be one pointer for looking at a NoSQL database where you have freedom to store more flexible data with a schema that might change from moment to moment. And the second question, do you have an enormous amount of data? And by enormous, I mean enormous. A good definition of this is described in the documentation for the popular HBase NoSQL database. It's asking, when should I use HBase? First, make sure you have enough data. If you have hundreds of millions or billions of rows, then HBase is a good candidate. If you only have a few thousand or a few million rows, a traditional relational database management system might be a better choice. So if that fits your needs, take a look at some of the projects that were specifically designed for that kind of data. What's being generically referred to as big data situations, which have a different kind of requirements from what people envisioned for classic relational databases 40 years ago. And the third option, valuing scaling over consistency. Well, what do I mean by this? You see, with most enterprise-level relational databases, traditional databases, they are oriented towards never losing a single thing. That's why such a focus on transaction. Because for things like banking systems or airline bookings or patient information, you just can't lose a thing. If, however, you have a different kind of setup, your database needs to crunch vast amounts of statistics on website hits, but no particular one entry is all that important, then you're more concerned with being able to scale really fast, to add machines, lose machines, add and lose disk drives, and still keep up and running, even if you lost an entry here and there. And some of the NoSQL databases are really more oriented to that kind of approach than the never lose a single row. So these databases are great, but make sure you're using them for the right reasons. Some people think, well, they're newer, they must be a more up-to-date way to approach relational database issues, but that isn't the case at all. These systems are trying to fix different kinds of problems. And if you have a problem that a relational database can't fix, then go ahead. If you need flexible schemas, vast amounts of data, just go for it. Though if you have well-defined data, don't underestimate the ability of traditional relational databases, even if it might not be the newest technology around. But for more on NoSQL, take a look at our Up and Running with NoSQL Databases course that gets deeper into some of these, particularly CouchDB.